I am Radhakrishna, your mathematics teacher. Today we are going to continue our topic circles, and we are going to solve some excellent problems in excellent methods. Let us take up the first problem. If two circles of radii A and B intersect orthogonally, then find the length of their common chord. Let us take two circles like this. Their radii are A and B, they intersect orthogonally. Let C1 and C2 be the centers of the two circles, and A and B be the points of intersection. Join the centers. C1A is A, radius of the first circle. C2A is radius of the second circle. This is B. The angle between the circles is pi by 2. The circles intersect orthogonally, so this angle is pi by 2. When the two circles intersect orthogonally, one very important property is the tangent at the point of intersection to any circle, any of the two circles, passes through the center of the other circle. So, this tangent at A to this second circle passes through C1, tangent at A to this first circle passes through C2. Okay. Now, if this is A, this is B, then what is C1, C2? C1, C2 is equal to, let us denote it by D. It is square root of A square plus B square. Okay. Now, we want length of the chord AB. So, joining the chord AB, we know the property that the common chord of two circles will be perpendicular to C1, C2, and also line joining the centers will be the perpendicular bisector of AB. So, if this is perpendicular bisector of AB, then this is the midpoint of the common chord. Okay. Now, if you want AB, first calculate AM and multiply by 2. Now, to calculate AM, we will calculate the area of the triangle C1A C2 in two different ways and equate them. Area of triangle C1A C2 is equal to, first, if the total length of AB is 2L, then AM will be L. Let the length of AB be equal to 2L. Then AM will be equal to L. Now, the area of the triangle is, as you know, half base into height, that is half into, what is the base? D, C1, C2 into L, height is L, AM. Now, the same area can be calculated in a different way, half into A into B. In area of a triangle is half into product of two sides of a triangle into sine of the included angle. So, it is half into A into B into sine of this angle pi by 2, A into B into pi by sine pi by 2, right. Now, cancel half, L is equal to AB into sine pi by 2, sine pi by 2 is 1, So, it will be AB by D, and what is D? Square root of A square plus B square. So, it will be AB by square root of A square plus B square, right. Now, we want AB. AB is equal to 2L. So, answer is 2AB upon square root of A square plus B square. So, this is the length of the common chord. Okay. Let us proceed to next question. Two circles of radii 4 and 9 touch each other externally. If a circle of radius r, touches their direct common tangent and also touches the two circles externally, find the value of r. Draw two circles touching each other externally. These two are two circles. Let the centers be C1 and C2. Then this is 4 and this is 9. Now, a circle of radius r touches their direct common tangent. So, let us draw the direct common tangent. This is direct common tangent, and a circle of radius r touches the direct common tangent as well as the two circles externally. So, I will draw the small circle touching both of them, touching both the circles externally and also touching their direct common tangent. Now, let this point of contact be A, this point of contact be B, and this point of contact be C. Now, if two circles are there with radii r1 and r2, the length of the direct common tangent is given by 2 root r1 r2. This is the formula. If you want, I can prove this is r1. One minute. If two circles are there with radii r1 and r2, then let us calculate the length of their direct common tangent. You join these two. This is r1, this is r2, right. Let the distance between the centers be d. Now, this angle is pi by 2, this angle is pi by 2. Okay. Now, from the center of this circle, first circle, draw a line parallel to the direct common tangent. So, like this. This is parallel to this. So, if this is r1, this is also r1, because this is a rectangle. This angle is pi by 2, this angle is pi by 2, this angle is pi by 2, this angle is pi by 2. So, it is a rectangle. Okay. Now, if you want the length of the direct common tangent, you have to calculate this length. Now, in this triangle, this angle is pi by 2, right. This is d, and this small length is r2 minus r1. This is r1, this is r2 now. So, this is r2 minus r1. So, what is this length or this length? it will be by Pythagoras theorem square root of, in this right angle triangle hypotenuse is D. So, square root of hypotenuse square minus R2 minus R1 whole square. Okay. So, this is the formula for length of the direct common tangent when two circles are non-intersecting and one outside the other. Similarly, if two circles, in this same case, if you want length of the transverse common tangent, the formula is square root of d square minus of r1 plus r2 whole square. So, remember the formula, length of the direct common tangent of two circles is square root of d square minus r2 minus r1 whole square. Length of the transverse common tangent is given by square root of d square minus r1 plus r2 whole square. Now, when two circles touch each other externally, then d will be equal to r1 plus r2. So, if you substitute d is equal to r1 plus r2, this is going to be square root of r1 plus r2 whole square minus of r2 minus r1 whole square. Then what is it? A plus b whole square minus a minus b whole square is 4ab. So, this will be root over 4 r1 r2. Okay. Then it will be 2 root r1 r2. So, this is the formula for length of the direct common tangent when two circles touch each other externally. Okay. So, I am going to apply this formula here. Okay. Let this radius is given as r now. In this diagram, AC plus CB is equal to AB. AC is length of the direct common tangent of this circle and this circle. So, applying the formula 2 root r1 r2, r1 is 4, r2 is small r. So, it is 2 root 4r plus CB. CB is the length of the direct common tangent of this circle and this circle. So, what is it? 2 root this into this, 2 root 9 into r is equal to AB. AB is the length of the direct common tangent of these two circles, the given two circles. So, it is going to be 2 root 4 into 9, right. Now, cancel 2, this is 2 root r plus 3 root r is equal to root 36 is 6. Then 5 root r is equal to 6. So, r will be equal to 36 upon 25. Radius of that small circle is 36 by 25. Okay. So, in this question, all of you need to remember the formula for length of the direct common tangent as well as length of the transverse common tangent. When two circles touch each other internally, externally, length of the direct common tangent is 2 root r1 r2. Okay. Proceeding to next question. It is a wonderful question. AB is a variable chord of the circle x square plus y square plus 2gx plus 2fy plus c is equal to 0. If AB subtends a right angle at the center, at the origin. Find the locus of the foot of the perpendicular from the origin on AB. Let us see it in the diagram. Let this be the given circle, it is fixed, and AB is a variable chord. AB is a variable chord, but how is the chord? It subtends a right angle at the origin. So, we can take origin anywhere. I am taking it inside. Okay. This angle is pi by 2. Now, AB is moving, AB is a variable chord, circle is fixed. Then what do you want? Locus of the foot of the perpendicular from the origin on AB. Drop a perpendicular like this. If the foot of the perpendicular is P, we want the locus of P. Then I am going to explain this in different methods. First method is, I will take P as x1, y1, method 1. Let P be equal to x1 comma y1. Now, if this is x1 comma y1, we can find out the equation of AB in terms of x1 and y1. How? OP is perpendicular to AB. What is the slope of OP? Y1 minus 0 by x1 minus 0, that is y1 by x1. Okay. Since AB is perpendicular to OP, the slope of AB will be minus x1 by y1. Right. Now, using the point x1, y1 and this slope, I will find out the equation of AB. Equation of AB is y minus y1 upon y minus y1 is equal to slope into x minus x1, that is minus x1 by y1 into x minus x1. Now simplify it, cross multiplying and simplifying, you are going to get x1 plus y1 is equal to x1 square plus y1 square. So this is equation of AB. Now this line subtends a right angle at the origin. So what is the property if a chord subtends a right angle at the origin? Method 1 we are discussing. The circle with AB as diameter, the circle with the chord as diameter passes through the origin, is it not? Because this angle is pi by 2, if you draw a circle, with AB as diameter, it passes through the origin. Okay. Now, if a circle and a line are given, how to find the circle with the chord as diameter? Any circle passing through the points of intersection of a line and a circle will be in the form of S plus lambda L is equal to 0, right. So, I will take S plus, S is what? The given circle, and L is this line. Now, any circle through A and B, any circle with AB as diameter can be calculated using the formula S plus lambda L is equal to 0. So, I will write S plus lambda L is equal to 0. What is it? X square plus y square plus 2gx plus 2fy plus c plus lambda into xx1 plus yy1 minus of x1 square plus y1 square. So, minus x1 square minus y1 square is equal to 0. This is S plus lambda L is equal to 0. Okay. We can simplify this as x square plus y square plus, taking x common from this and this, 2g plus lambda x1 into x plus 2f plus lambda y1 into y and what is the constant? C minus lambda into x1 square plus y1 square plus C minus lambda into x1 square plus y1 square is equal to 0. This is any circle passing through the points of intersection of this line AB and the given circle. Now, if you want circle with AB as diameter, then the center of this circle should lie on AB, is it not? So, what is the center? Center of the circle is, all of you know the formula, minus g comma minus f, that is minus of, what is g? Half of the coefficient of x. It is 2g plus lambda x1 by 2 comma minus f. Minus f is minus of this by 2, minus of 2f plus lambda y1 by 2. This is the center. It lies on AB. If this lies on AB, so substitute it in the equation of AB. So, x coordinate is here, x1 into this minus of 2g plus lambda x1 by 2 into x1, next plus y1, this into y1 minus 2f plus lambda y1 into y1 by 2, xx1 plus y1 is equal to x1 square plus y1 square. Okay. Now, simplify it, cross multiply by 2 and numerator becomes minus 2 into gx1 plus fy1 minus 2 into gx1 plus fy1 minus lambda into x1 square plus y1 square is equal to 2 into x1 square plus y1 square. Right. So, calculating lambda from this, lambda will be taking it this side and this one this side, minus 2 into x1 square plus y1 square minus 2 into gx1 plus fy1 upon x1 square plus y1 square. Okay. Now, if this circle passes through the origin, then automatically AB subtends a right angle at the origin. So, if this circle passes through the origin, substitute the origin, this will be 0, this will be 0, this will be 0. So, substituting the origin, this equation becomes C minus lambda into x1 square plus y1 square. So, taking C is equal to lambda into x1 square plus y1 square, the circle passes through the origin. Now, this lambda and this lambda must be same. Okay. So, I will substitute this lambda into x1 square plus y1 square here as C. Then I will get the locus of the point x1, y1. Let us see. No need to calculate lambda here. Directly I will substitute lambda is into x1 square plus y1 square as C. Then minus 2 into gx1 plus fy1 minus C is equal to 2 into x1 square plus y1 square. Okay. Then taking these two terms to RHS, what will you get? 2 into x1 square plus y1 square plus 2 into plus 2gx1 plus 2fy1 plus C is equal to 0. This is the condition we get. Then after getting the condition, how will you get the locus? Replacing x1 by x and y1 by y, we get the locus. So, the locus of P is replacing x1 by x, y1 by y. This is our answer. This is the locus of the point P. This is method 1 and very long method. Okay. Now, let us see the second method. In the second method, what I am going to do is, in first year or 11th, you might have studied about homogenization of a curve and a line. If a curve and a line intersect each other, then we can get the pair of lines joining the points of intersection and the origin by homogenizing the equations of the curve and the line. Now, assuming that Px1 y1, we get the equation of the line like this. Here, from here, I will homogenize this equation with the equation of this circle. Then I will get the pair of lines joining the points of intersection and the origin. Let us see. I will rub off from here. This is method 2. Method 2. Till finding the equation of L, it is same. Now, homogenizing with the equation of the circle. Homogenizing with the equation of the circle. What is homogenization? Using this equation and this equation, we will get a second degree homogeneous equation. For homogenizing, we have to write this equation as xx1 plus yy1 by x1 square plus y1 square is equal to 1. We should write this as xx1 plus yy1 by x1 square plus y1 square is equal to 1. Now, these two have second degree, these two have first degree. Now, how to raise the degree to 2? I will multiply this first degree expression by this. Meaning is we are multiplying by 1 only. Multiplying this and this, we get second degree. And C is a constant. How to raise the degree to 2? We will multiply this whole square here. So, by homogenization, we get the equation x square plus y square plus 2gx plus 2fy into multiply by xx1 plus yy1 by x1 square plus y1 square. Okay. Then multiply the constant C by xx1 plus yy1 whole square by x1 square plus y1 square whole square is equal to 0. Now, this is the homogenized equation. This all terms have same degree 2. It is a homogeneous equation. Now, this equation represents the pair of lines OA and OB. This is pair of lines OA and OB. Now, if angle AOB is pi by 2, what is the condition? If the homogeneous equation, which is pair of lines through the origin, represents two perpendicular lines, then coefficient of x square plus coefficient of y square is equal to 0. So, if angle AOB is equal to pi by 2, then coefficient of x square plus coefficient of y square is equal to 0. So, without expanding the equation, I can find the coefficient of x square. Here 1 plus, in this product, what is the coefficient of x square? This into this, that means 2g x1 by x1 square plus y1 square. 2g x1 by x1 square plus y1 square. Next, coefficient of x1 square, x square here will be c into x1 square by x1 square plus y1 square whole square, plus c into x1 square by x1 square plus y1 square whole square, plus coefficient of y square 1 plus, in this product coefficient of y square will be 2f into y1 by this 2f y1 by x1 square plus y1 square whole square. Next, in this coefficient of y square is c into y1 square by x1 square plus y1 square whole square, plus c into y1 square by x1 square plus y1 square whole square is equal to 0. Now, if you multiply this whole thing by x1 square plus y1 square whole square, then that equation becomes this equation. You will get 2 into x1 square plus y1 square plus 2g x1 plus 2f y1 plus c is equal to 0 you will get. Then converting x1 to x and y1 by y, you are going to get the same locus. But even this method is also a bit lengthy. Okay. Now, let us see the magic, the third method and the best method. In this method, I am going to apply a simple property of a right angle triangle and the definition of power of a point. Method 3. Very magical method. Even many teachers also solve the same question in method 1 and method 2, and method 2 is method 3 is rarely used. So, observe it carefully. This is the diagram. P x1 y1 is the foot of the perpendicular. I am going to apply a simple property of a right angle triangle. If OAB is a right angle triangle with right angle at O, then OP square is equal to PA into PB is the property. OP square is equal to PA into PB. I hope you must be aware of this property. Now, PA into PB, this is product of the sine distances, but I am going to take lengths. So, mod OP square is equal to mod PA into PB. I am considering lengths. What is P x1 y1? What is OP square? X1 square plus y1 square. So, LHS is x1 square plus y1 square, and this PA into PB is nothing but power of the point, is power of the point Px1 y1, power of the point is nothing but S11. So, this is equal to mod S11. but since P lies inside the circle, because P lies on AB now, AB is a chord, so P must be inside the circle. When point P is inside the circle, power of the point is negative, so S11 is negative. So since S11 is negative, what is mod S11? It is minus S11. That is minus of, what is S11? X1 square plus Y1 square plus 2gx1 plus 2fy1 plus c. Now taking this side, you are going to get 2x1 square plus 2y1 square plus 2gx1 plus 2fy1 plus c is equal to 0. We got the condition. Then converting x1 and y1 to x and y, directly we will get the locus. Only 2-3 steps. Okay. Now moving to next question. P and PB are tangents from P1, 2 to the circle x square plus y square plus 4x plus 6y plus 2 is equal to 0. Take a circle. This is a circle. Tangents from P1, 2 are PA and PB. This is A, this is B. P is 1, 2. Now 1, 2 clearly lies outside the circle. If you substitute 1, 2, you will be getting power positive. So point is outside, so we can draw two tangents from P. Now we have to find the equation of the line passing through the midpoint of PA and PB. So suppose this is the midpoint of PA, this is the midpoint of PB. Now we want the equation of this line. Here usually many students will find the equation of AB. AB is chord of contact of P with respect to this circle. You can get it by the formula S1 is equal to 0. Then this line is perpendicular to the line joining the center and P. Then they will somehow try to calculate the equation of if this is midpoint, if these two are midpoints of P and PB, then this line will be exactly in the midway between P and this line. So you can draw a line through P parallel to this line. First you will find chord of contact of P by using the formula S1 is equal to 0. Then you can find the equation of the line through P parallel to this chord of contact. Then we can find the line in the midway between these two. Okay, but that method is lengthy. We can solve it using the concept of radical axis. If two circles are like this, radical axis will be some line between the two circles, and the important property of radical axis is it bisects the common tangents. This radical axis bisects this common tangent as well as this common tangent. So if these two points of contact are A and B, these two are C and D, then this radical axis is nothing but the line passing through the midpoints of AB and CD. Okay. Now you think what happens if this circle becomes point circle. If this circle becomes point circle, it becomes this diagram, is it not? Then how do you get the equation of AB? If this circle becomes point circle, then this becomes this diagram. So how can you get the equation of this required line passing through the midpoints of PA and PB? Find the equation of this point circle. What is this point circle? Point circle of P 1, 2 is, point circle will have radius 0. So, x minus 1 whole square plus y minus 2 whole square is equal to 0. Expand it, x square plus y square minus 2x minus 4y plus 5 is equal to 0. Now, this circle is x square plus y square plus 4x plus 6y plus 2 is equal to 0. What is the radical axis of this circle and this circle? All of you are aware of the formula, radical axis is s minus s dash is equal to 0. So, radical axis of I will write this as s is equal to 0, this as s dash is equal to 0. Now, radical axis of s is equal to 0 and s dash is equal to 0 is s minus s dash is equal to 0. Find s minus s dash, this minus this, 4x minus of minus 2x, 6x. Next, 6y minus of minus 4y plus 10y. Next, 2 minus 5 is minus 3. What is this line? It is the equation of the line bisecting PA and PB. So, the answer is this line. This is the equation of the required line. It is finished. Moving to next question. Find the locus of the inverse points of points on the line 2x minus 3y plus 5 is equal to 0 with respect to the circle x square plus y square is equal to 25. Let us take the circle like this and that line like this. Locus of the inverse points of points on this line. Let us take a point on this line. How do you get its inverse point? We should draw polar of P. How do you get the polar of P? When P is outside, polar of P is nothing but chord of contact of P. So, draw chord of contact of P. These two are tangents. So, this is the chord of contact of P. Then what is the inverse point? If this chord of contact will be perpendicular to line joining the center, which is origin, and P. Okay. Now, the polar of the inverse point of P is nothing but this point of intersection. Let it be Q. Okay. So, this is the definition of inverse point. Now, you want the locus of Q. If P is the inverse point of Q, then inverse point of Q will be P. If the inverse point of P is Q, inverse point of Q will be P. Let us take Q as x1 comma y1. I am going to find the inverse point of Q. Let Q x1 y1 be the inverse point of P. Then the inverse of Q, inverse point of Q is P. So, how to find the inverse point? Write the polar of Q. Polar of Q is S1 is equal to 0, xx1 plus yy1 is equal to 25. Okay. Now, the foot of the perpendicular from the center to this polar is nothing but inverse point. Okay. Then inverse point is given by foot of the perpendicular formula. If h comma k is foot of the perpendicular, h minus 0 by x1 is equal to k minus 0 by y1 is equal to minus of 0 plus 0 minus 25 by x1 square plus y1 square. Then what is the inverse point? P is equal to, find h and k, it will be 25 x1 by x1 square plus y1 square comma k, k is 25 y1 by x1 square plus y1 square. Okay. Now, this P lies on this line. So, substituting P in that line 2x minus 3y plus 5 is equal to 0, you are going to get a condition on x1 and y1 which gives the locus of Q. Let us substitute in that line, substituting in 2x minus 3y plus 5 is equal to 0. You will get 2 into 25 x1 by x1 square plus y1 square plus minus 3 into 25 y1 by x1 square plus y1 square plus 5 is equal to 0. Then simplifying it or multiplying both sides by x1 square plus y1 square, you will get 5 into x1 square plus y1 square plus 50 x1 minus 75 y1 is equal to 0. So, finally, dividing by 5 and replacing x1 by x and y1 by y, you will get x square plus y square plus 10x minus 15y is equal to 0. This is the locus of the point Q. Okay. So, this is the answer. We will move to next question. A very important conceptual question. The center of the circle S is equal to 0 lies on this line, and S is equal to 0 cuts the circle x square plus y square is equal to 4 orthogonally. Then S is equal to 0 passes through which of these 4 points? Let us take S is equal to 0 as x square plus y square plus 2gx plus 2fy plus c is equal to 0. S is x square plus y square plus 2gx plus 2fy plus c is equal to 0. Center lies on this line. What is the center? Minus g minus f. Substitute here. You will get minus 2g plus 2f plus 9 is equal to 0. So, center lies on this line. Now, S is equal to 0 cuts this circle orthogonally. If S is equal to 0 cuts x square plus y square is equal to 4 orthogonally. What is the condition if two circles intersect orthogonally? The condition is 2 into g1 g2 plus f1 f2 is equal to c1 plus c2. 2 into g1 g2 plus f1 f2 is equal to c1 plus c2 is the formula. Here in this circle g and f are 0, coefficient of x is 0, coefficient of y is 0. So, this will be 0, this will be 0. 2 into 0 plus 0 is equal to c1 plus c2. c1 is minus 4 and c2 is c. So, c minus 4, we get c is equal to 4. Okay. Now, the question is S is equal to 0 passes through which point? Now, let us substitute c is equal to 4 and we can substitute 2g from this in terms of f. So, S is equal to 0 becomes from this circle, S is equal to 0 becomes x square plus y square plus 2g can be substituted as 2f plus 9 plus 2f plus 9 into x plus 2fy plus 4 is equal to 0. Okay. But we cannot find f, there will be many circles. Now, you can write this equation in the form of s plus lambda L is equal to 0. It is x square plus y square plus 9x plus 4. What is the remaining? 2fx plus 2fy, that is plus 2f into x plus y is equal to 0. F is a parameter just like 2f is equal to lambda. Now, this is fixed circle, this is fixed line. It is in the form of s plus lambda L is equal to 0. The line if the line L is equal to 0 intersects the circle S is equal to 0, then any circle through the points of intersection will be in the form of s plus lambda L is equal to 0. So, if at all this line intersects this circle at 2 points, then this circle always passes through those 2 points. So, we have to find the points of intersection of this line and this circle. What is that line? X plus y is equal to 0 means y is equal to 0, y is equal to minus x. Substituting in the equation of the circle, we will get x square plus x square, 2x square plus 9x plus 4 is equal to 0. Then what are we getting? 2 into 4 is 8. We can write 9x as 8x plus x, 2x square plus 8x plus x plus 4, taking 2x common here. So, finally, you will get x is equal to minus 1 by 2 or minus 4. X is equal to minus 1 by 2 or minus 4. Then, if you find y, and here there are two options, option B and option D. We will have x is equal to minus 2 and x is equal to minus half. So, they must be correct. You also check with y coordinates by substituting x here. You are getting, if y is equal to minus x, for x is equal to minus half, y will be plus half. So, this point is correct. If x is equal to minus 4, then y will be plus 4. So, these two are the correct options. The circle always passes through minus 4 comma 4 and minus 1 by 2 comma 1 by 2. Find the minimum value of x1 minus x2 whole square plus 5 minus 2x1 minus root over 1 minus x1 square, I think, x2 square. To find the minimum value, this expression looks like distance formula. You know that distance formula is square root of x1 minus x2 whole square plus y1 minus y2 whole square. So, if you take square root and assume that this is y1, this is y2, it becomes exact distance formula. So, what you want is, you want the minimum value of the square of the distance between 2 points. So, let us assume that the points are A x1 y1 and B x2 y2. Then this is nothing but AB, taking square root. Now, y1 is equal to 5 minus 2x1 or 2x1 plus y1 is equal to 5. So, A lies on a fixed line, and check B, y2 is equal to root over 1 minus x2 square. This becomes x2 square plus y2 square is equal to 1. What is it? A circle. So, A lies on a fixed line, B lies on a circle. Let us take the diagram. This is the circle, x square plus y square is equal to 1, and 2x plus y is equal to 5 is a straight line like this. Now, you want the minimum distance of any point on this line from any point on this circle. How do you get the minimum distance between a circle and straight line? Joining the center, from center you draw a perpendicular line, then this length is going to be the minimum distance between the line and the circle. So, the minimum distance of AB is this when A and B are here. How to calculate it? Find the perpendicular distance of the origin from the line. What is that line? 2x plus y is equal to 5. So, what is OA, perpendicular distance from the origin? 5 by root 5, it is root 5. So, this length is root 5 and minus OB, OB is radius of the circle 1. So, AB will be or AB minimum is root 5 minus 1. Okay. Then the given question is without square root. So, it is AB square. So, AB square minimum is root 5 minus 1 whole square. So, our answer is root 5 minus 1 whole square. Okay. Now, I am going to take up the questions and answer session after a minute. Hello students, welcome back. So, let us take up the questions and answer session. First question. There is one question asked by Mr. Vijay Sri. Two orthogonal circles passing through 0 comma a and 0 comma minus a touch the line y is equal to mx plus c. Then find the condition. Two orthogonal circles passing through 0 comma a and 0 comma minus a touch the line y is equal to mx plus c. Where are 0 comma a and 0 comma minus a? They are on y axis. If this is x axis, this is y axis, 0 comma a will be here, 0 comma minus a will be here. There are two orthogonal circles passing through these 2 points. So, let us draw two circles like this, one like this, another like this. The two circles are intersecting each other orthogonally and both of them touch the line y is equal to mx plus c. So, y is equal to mx plus c is a common tangent. So, this is the given information. Now, based on this, first I will find out the general equation of a circle passing through 0 comma a and 0 comma minus a. First I will take circle with line join the 2 points. Let the 2 points be a and b. Take the circle with AB as diameter. Equation of the circle with AB as diameter will have center at origin and radius a. So, what is the equation of the circle? X square equation of the circle with AB as diameter is x square plus y square is equal to a square, and the equation of AB is nothing but y axis. AB is nothing but y axis, no? Its equation is x is equal to 0. Now, this x is equal to 0 intersects this circle at A and B. So, any circle passing through A and B can be taken as S plus lambda L is equal to 0. So, let the equation of the circle be x square plus y square minus a square s plus lambda l is equal to 0. Lambda into plus lambda into x is equal to 0. So, this for any value of lambda, this circle passes through A and B, but it is given that two circles are there. So, I will take lambda 1 for one circle and lambda 2 for another circle. But for our convenience, we may take 2 lambda 1 and 2 lambda 2, nothing wrong. Lambda 1 and lambda 2 are any parameters. So, even if you take 2 lambda 1, 2 lambda 2, no problem. Okay. So, I am taking two circles passing through A and B. For any values of lambda 1 and lambda 2, they pass through A and B. So, this condition is fulfilled. Now, both of them touch the line y is equal to mx plus c. If a line touches the circle, what is the condition? Perpendicular distance from the center is equal to radius. What is the center of the circle? Minus g comma minus f now. So, minus lambda comma 0 is center of the circle, where lambda may be lambda 1 or lambda 2. And what is the radius? Root over g square plus f square minus c. G square means lambda square, f square is 0, minus c is plus a square. Now, perpendicular distance from this point to that line is mod minus m lambda. Here lambda may represent lambda 1 or lambda 2 plus c by root 1 plus m square. This perpendicular distance should be equal to radius of the circle, root over lambda square plus a square. Now, cross multiplying and squaring, we get minus mc m lambda plus c whole square is equal to lambda square plus a square into 1 plus m square, right. Now, let us expand this. M square lambda square minus 2 mc lambda plus c square is equal to same. But here lambda may be lambda 1 and lambda 2. Okay. Now, it is a quadratic equation lambda. If you want, you can simplify it further. If you multiply these two, you will get 1 plus m square into lambda square plus a square into 1 plus m square. So, m square lambda square cancels. Okay. So, you are going to get lambda square plus mc lambda 2 mc lambda. Okay. Plus a square into 1 plus m square minus c square is equal to 0. It is a quadratic equation in lambda. Now, we have not yet used one condition. What is that condition? The two circles are orthogonal to each other. Okay. If the two circles are orthogonal to each other, what is the condition? 2 into g1 g2 plus f1 f2 is equal to c1 plus c2. 2 into g1 g2 means 2 into lambda 1 lambda 2 plus f1 f2 is 0 is equal to C1 plus C2. C1 and C2 are same, minus a square plus minus a square is minus 2a square, 2 cancels. So, lambda 1 lambda 2 is minus a square. If lambda 1 and lambda 2 are the roots of this equation, lambda 1 lambda 2 will be product of the roots. What is product of the roots? This by 1, a square into 1 plus m square minus c square is equal to minus a square, right. Then taking minus a square this side, you will get a square into 2 plus m square is equal to c square. So, we got the required condition. Okay. So, time is up. So, we are going to close the session for today and we are going to continue in the next class. So, we are almost going to complete the topic. Tomorrow, another sir, Sridhar Babu sir will come and solve some additional questions, and the next I am going to start the calculus part, indefinite integration. Okay. So, until then, have a good day.